We'll talk about those in the utilities while writing the BTEC scripts and all in Teradata. So I'll tell you what are those BTECs and all. Okay. So this is about the space management, and the other one is the hashing algorithm and the primary index of Teradata. So because all your Teradata systems runs on index concept here, unlike Oracle or SQL Server, the primary key concept. In Teradata, everything is the data is distributed based on the primary index, secondary index, unique primary, non-unique primary index. So everything is based on the indexing mechanism. So we should have in-depth knowledge of indexing in Teradata to understand the performance, or so that you can do some performance tuning in your queries. Because what happens in real time, you may come across some kind of enhancement where we need to tune your existing BTEC scripts. So in order to do that, you should have a solid fundamental knowledge of indexing and the space management, I mean the spooling issues, so that you can actually optimize your queries to reduce the time that is consuming for the query. Okay, this is very important concept in Teradata, so we'll be covering that topic as well. So the indexing, basically how the indexes will work. After that, we'll talk about the different type of indexes in Teradata, like partition primary, multi-level primary index, join hash, and blah blah blah. So there are different kind of indexes which is used based on the requirement. So we'll talk about each index in detail with an example from the table, and with the data we'll show you how it will work, because this is not theoretical process. Okay, for example, for your information, only the first introduction will be theoretical, the remaining all are all and hands-on training. So we'll give you some example before we telling something on that. For example, if you say PPA, we'll create a PPA index on a table, and we'll show you how the data is distributed, I mean how it is being called in the table, right? So we'll be talking about the indexes as well, and with the live example. After that, we'll have the, this is as part of your SQL, like inner join, cross joins, and all the stuff. And here the SQL data types, string functions. I think you might have aware of the SQL, but there is no difference between other SQL and Teradata. Only thing is maybe the syntax might be little different, but the SQL is remain same. All the data types, case statements, everything, casting function, formatting, everything remains same. But we'll talk about SQL as well. Okay. And finally, we'll come to utilities. Utilities are nothing but Teradata as a special features. They have invented some concepts called utility, which will be indirectly used to load the data or export the data into some files. We use kind of different utilities in Teradata. So there are like fast load, mload, fast export, fload, and BTEC. So BTEC is a common used utility. BTEC is nothing but basic Teradata query, which is used to load the data in terms of, this is kind of like a procedure kind of stuff, where you keep multiple sequences in an order and error handling mechanism in between. It's like you can call multiple sequence statements here, so that you can do the entire ETL stuff in BTEC itself. So 70% of your real-time work is based on the BTEC utility, okay, for Teradata. So if you're really working on Teradata projects, you might have aware of this, because most of your Teradata work will be lying under BTEC scripts. So we'll be talking about that utility and how to write a BTEC script and how to call and execute the BTEC scripts and all the stuff. Okay, that is about the utilities. And finally, while coding, what is the best practices and some examples with real-time case scenarios will provide you, okay, along with the assignments for each and every utility. So this is on a high level of the course content. So any questions on this? Ramya or Srinivas?
Yeah, Raj, I have a question. Why we are going for Teradata? Like, I think to be more specific, I have a doubt on this architecture. So you said Teradata follows parallel architecture, right? Parallelism.
Yeah.
So how does it differentiate from the other database like Oracle or?
Yes, yeah, I can tell you that. So
Mm-hmm.
to so as part of the architecture here, if you see, so the parsing engine is common in every database. Parsing engine will, what basically does is when your query is written by the user, right? So basically, we'll have the query passed by parsing engine with respect to the syntax. First of all, it will verify for the syntax. If it is correct, then it will just check the explain plan. I think you might have heard of this term, right? Explain plan is basically gives you tell you like what exactly you're doing with respect to your resources and all that stuff. So I'll give you a simple example in the database so that you'll get a better idea. So this is the Teradata software that you're going to install on your laptops. This is the VMware server where the Teradata 14.0 version. So that we are currently using, and this is a front-end tool basically, which will be connecting to this Teradata database. Okay, so I'll just give you a simple scenario how the parallel processing, how the processing will work. You're asking for the architecture, right? So I can just
Yeah.
give you a simple definition. So this is completely on the Linux system Teradata. For those who don't know, this is a Teradata system what I'm currently showing here, and this is a VMware, and this is your client on your local desktop. You can connect to the SQL assistant to write any kind of queries. I'll just show you all these things once connect, like how to install software and connection. Don't worry. So let me just show you. So for example, I'll just show you the data from select star from students table. Okay. So I have 5 records in this table. Okay. And I'll just show you the structure of this database. The table. If you say so select star from students, this is the you know the data for the definition of the table. So if you see here, the primary index is on the name column, and there are four column: name, subject 1, subject 2, subject 3, and name is having the primary index, and index is nothing but secondary index. Until unless you mention as a primary, it will be secondary. So secondary is on the subject 1. So what I will write a query now, if I say select star from students, I will just show my explain plan, because you are trying to get the data from the table completely, right? So if you say explain plan for this, you can write either explain select start from student and execute. That will give you explain plan, or F6 is also fine. Press F6 by selecting the query. That will give you the explain plan here. So if you see the explain plan, this is what your parsing engine will does. Okay, as per the architecture here, what are the parsing engine is doing here, it will just show in this explain plan saying that first we log the table to read a row hash to prevent a global deadlock on this table, so that the others cannot be read at the same time. Okay, to have this lock on the table. And now here uh, we do an all amp retrieval step from student by way of an all row scan with no residual conditions. This statement is very important because it is saying that we do an all amp retrieval. So in Teradata, we have a concept called AMP, Access Module Processor. So whenever a query is coming in, the parsing engine will guide the AMPs to distribute the data and get the data accordingly based on the row hash values. Okay. So Binet is like a communication mechanism between parsing engine and the AMPs. So AMPs basically does all these operations. It will get the data from the disk storage, and the AMP will do some calculations, whatever aggregations and all, it will be done at AMP level, and it will get the data to Binet, and Binet will send it to parsing engine. So here the catch is the rows will be distributed among different AMPs for a table. For example, if the Teradata system have 4 amps, the data will be distributed equally when you create a table and distribute the data. Okay. And when you say select star from students, what happens is it will try to search all the amps with respect of the condition, because we are doing the all row scan. So in this case, what happens is normally select star from table name is the very costliest query in real time, right? We don't write really select star from table name. So, and now if you wanted to see like what is a efficient way of doing it. So if I just put a condition where name is equals to Joel, for example. So if I do the explain plan after this, okay, I have to do the both explain plans to differentiate. First of all, to not to close this, and then I'll just show you difference between two explain plan. Basically here we do an all-am retrieval. Now if you say select star from students where name is equal to Joel, let's say, here it's saying that first we do a single amp retrieval step from student by where the primary index name is equal to Joel with no residual conditions into spool 1. So here what happens is I use a primary index as a condition where name is equal to something, right? Because name is the primary index defined on the name column. So if I use the condition name as Joel kind of the structure, it is a single amp operation. So here the parsing engine will tell that okay, we have a corresponding row hash value for the given query because the primary index is defined, so that it will directly go to the respective hash value in AMP and get the data. So here the parallel processing is whenever you say any cell start from table name, for example, if there are more than one row written, it might be saving in more than one AMP. So whenever you write the query, so that it will just generate the data parallelly from all the amps and get it to the parsing engine. Okay, so here there is no sharing between two different amps, and the data can be distributed in any random order. There is no particular order the data will be distributed. For example, if you have 100 rows, maybe here 25 will be stored, all 25s, but the order will be different, like not 1 to 25 should be there in amp, not necessarily for that. It can be anything, like I can store 2 to 10 records here and then again some other records, irrespective of order. So that will help in parallel processing because whenever you use the condition, it won't check for the order and therefore the data processing will be faster. So it's based on the hashing algorithm. It will directly check for the table, and if you have a primary index, it will directly go to the corresponding AMP to get the data. Okay. So that is a high level overview on the parallel processing. We'll be talking about in detail when we start in the sessions for the architecture.
Okay. Okay, Raj. Yeah. Thank you.
You clear any questions on this? The distribution. Here I'm into the queries.
Queries, I am really not sure because I haven't worked on SQL.
Okay.
I just know the basics, so I have to brush through the concepts of SQL.
Yeah, that is fine. I mean, because this will cover both SQL and the advanced concept. That is fine. So as long as you understand the basic, that is fine. So that we can go ahead with that. So I mean, just showing that how the data will be distributed here with respect to the architecture, because the explain plan, this is called explain plan, which is very important for Teradata to understand how a query works and the data distribution can happen. So based on that, we'll actually tune the queries, and we'll provide you with the software. So the software you can download from Teradata website itself, because this is a licensed version for not commercial use, non-commercial use. So you have to first of all install the VMware player. We'll provide you the instructions how to install it and how to connect to your local desktop. Okay, so this is the version that you have to download. Teradata Express /10 4 GB is fine for you, and the Teradata SQL Assistant, there's another package for this, and the VMware player. This is the VMware player. Okay, we'll provide you the instructions with the software, and so that we have a requirement that we should have at least the processor should be i3 or i5 or i7. Okay, so I hope you have the latest version of your laptops, because there's a concept called virtualization in the laptops which will not support the lower environment like before i3 processors. And Teradata cannot be installed on the lower version of the processor like i3 before i3 like Pentium processors. We have to get i3 or i5 or i7 processors for Windows, alright, for your laptops to install Teradata. Okay, and this is a course content that we're going to cover. All these details will be sharing to you. Okay, so you can just go through them in detail, and I'll just show you. I mean, just tell you like what are the real-time uses of Teradata, right? So, for example, if you have a client called Walmart, the biggest retailer in the world, so they use Teradata. So, what is a Teradata used for them, right? Just classic example I can give you. So, they have a, let's say they have a product, let's say product ID, let's say Nikon camera. Product ID is 1234 and product name is Nikon, and the sales data, sales per year. So basically they have some kind of statistics like sales per year, percentage of profit, and let's say number of service complaints. So something like this, overall rating. These are some kind of figures basically, to have it for Nikon camera. This is an aggregated information which is loaded through, let's say Teradata. Number of service complaints per year is 125. So overall rating we got 3 out of 10. Let's say I'm just giving the random figures, not maybe realistic. So here what I'm saying is, let's say I'm the sales manager of a company like say Walmart. I have to see whether I have to order a new product, a new inventory for the product called Nikon cameras. So before that, what I do normally, I'll check the inventory for the stock first, and that the stock is limited and it is going to end in the coming month. So I have to order for a new stock. So before that, what exactly I wanted to examine or analyze basically, like how many, like how much sale that has been done from the last 5 months or last 1 year, and what is the percentage of profit that I am receiving on this product, any service complaints and overall rating of the process customers. So what are the different regions that this product might not be used so good in the this area of some states. So I can do some kind of analysis on this data, because this data will be stored in the terms of OLAP. OLAP is nothing but some aggregational data, analytical data. So this is not a plain transaction. The transaction might be like customer ID, customer name, date of purchase, price of the camera, okay, and address of the customer, because it will be customer detail, right? This is called transaction. So transaction can be anything. Let's say there might be 100 customers bought this, and overall we got this aggregated data based on those 100 records. So what happens is, here I will analyze this data further and I will say, okay, I have to see, because I've got out of 3 rating out of 10 and I see the customers are not really satisfying with this product. So I have to do something else. Either I have to shift to other vendor like Canon or something else. Otherwise I have to improve the product quality, get the different brand version of this Nikon camera, the latest one. Something like that. They will get some kind of analysis on this data. Not only analysis, they'll get some classical figures as well. For example, if they see the sheet, the graphical sheet, so they see how much sale has been done for this product and how much time, I mean how much profit, and all the statistical things can be done by using the ETL processes in Teradata. Because at the end of the day, Teradata is nothing but a data storage, right? So whatever way you wanted to load, it can do for you. By using the transformations we do, transformation is nothing but, for example, you might have different vendors for the product, which is the source system, and they'll send the data every day by using different names. For example, Nikon Limited, and someone sends Nikon Cameras Limited, okay, and Nikon cameras. So the vendors, I mean, whoever is taking the products from Walmart, they may send the data back to Walmart by with different notations. For example, like this. But in the final system, that is data warehouse, you wanted to load all these things into a unique name, like saying that Nikon Cameras Limited USA. Let's say this is what you're actually wanted to load new data warehouse in a single name. So I can convert all these names which are coming from the source. I will convert by using any decode or case statement in my SQL, and I will convert if this name is coming Nikon Limited. I wanted to put as Nikon Cameras Limited. If it is coming like this also, I will be using this name to be populated in my data warehouse, the end load tables, so that I will have a 1234 ID will have a Nikon Cameras Limited USA only, one unique name, so that the integrity will maintain for the data, right? That is what the data warehouse. So some famous scientists defined data warehouse as a subject-oriented, integrated, non-volatile data used for strategic decision making process. So this is the famous definition of a data warehouse. So subject oriented in the sense we can have different data modes in Teradata, like in different databases. I mean, any database you can say subject oriented in the sense based on the areas we can actually store the data, like finance, administration, marketing, and all the stuff. And integration is nothing but, as I told you, from different sources here I just integrated into single source system with a unique name, that is integration. Non-volatile in the sense data warehouse data won't be deleted, and we won't change it often. We'll just load the data and most of the times. Data used for decision making process. So decision making process is nothing but whatever I told, to take a decision whether to order a new inventory or something like this. That is a decision, right? From the what do you say, the system, the business analyst or the managing directors, they will look at the analytical data and they will go with the decision whether to order a new product or extending the inventory in the showroom, right? So this is all happen at the back end, which we don't know on the data analysis, and which plays a very key role in terms of the data warehousing, because everywhere is data. So based on this only they can run the business. That's why ETL is actually a growing market in today's world. So any other questions on this?
Sir, this is Srinivas.
Yeah.
So where do you do the transformation? Like Oracle has SQL and PL/SQL, something like that, and Teradata also has SQL and procedural language here.
Yeah, as I told you, there are some utilities in Teradata, right? So in BTech, for example, the basic Teradata query, there are some utilities in the SQL is actually copied in BTech itself. BTech is nothing but a SQL only. Okay, so we kind of do all kind of transformation within the SQL itself and load the data. For example, in the BTech script, let me show you how it will look like. I'll just give you a sample script for BTech. So, for example, here this is a sample BTech script which I'm showing here. So here I just drop the table, created a table, insert the table here, and I just do some kind of select statement, or while inserting the data itself. Once the data is loaded, I can actually do some kind of transformation by using the case statement. For example, case, if the name is Mike, I wanted to do something else, right? So we can use all kind of SQL in the BTech itself to do all transformations within one script. This is basically kind of a procedure. In your Oracle terms, it's like a PL/SQL procedure. So we can have handle error mechanism here, and we can do all kind of DDL, DML here, so that you can do anything here, like with respect to the transactions. So we can do step by step, and finally till the target table you can do all kind of transformations without any issues. Okay. So the BTech is the major one which can do all kind of these transformations with respect to business logic. You clear on this, Srinivas?
Yeah, clear, sir. Yeah, thank you.
No problem. So that is how they actually process by using the BTech scripts mostly. Alright. So that's about the BTech scripts where we use it in real time most of the times. So it's very simple. I mean, though there are some BTech commands will be there. Only thing is if you know SQL a better way, you can write any kind of BTech scripts. BTech is nothing but you keeping the SQL in an order with a proper Teradata syntaxes for the BTech commands. So indirectly you are calling the SQL inside a file. Okay. So we should know Unix also a bit for the basic level because Teradata runs on Linux version only. Here is Teradata client, whatever I am showing, this is a client. Client can be installed on Windows, but the server is on the Linux version. So to want it to manipulate some data or some kind of execution, we should need the Unix knowledge, the basic commands, how to check for a file, how to move to a directory. All this basic Unix command we should know as a Teradata developer. Okay, so that is about the Teradata high level and the course content, the software. So I have discussed all this stuff, right? So course content we have already seen, and software details we checked it, and the duration, right? That is important. Duration is actually there are 8 sessions in this one, right? So 8 sessions basically take 16 hours. For each session will take 2 hours at least. So if you take 16 to 20 hours, I think it will go till 20 hours because the utilities will take little time because we need to practice as well, right? So the total duration is 20 hours online training. So we can do daily 1 hour, mostly 5 days a week. So that will take a weekend off. So 5 days a week, daily 1 hour. Based on your availability, we can fix the timings. Okay, and important thing is we'll send the recording on the same day. The recording in the sense uh, whatever we discussed in the classroom, it will be sent in the format of recording with video and audio both, so that you can practice and go back to your when you get a free time, you can go back to the recording and try to understand, and you can pose any question in the next class. Okay,
Okay, sir.
and
Good. Yeah.
assignments will be given based on the daily classes once you get into the utilities and the SQL kind of stuff, so that you guys can write some kind of queries and get some kind of questions in case you have any for the assignment. So these are the things that we're going to cover.
Raj, how about the installation on Mac? It shouldn't be a problem, I guess, right?
Yeah, Mac, I think Teradata, we have version on Mac, we have to explore that because normally we get Windows laptop for students most of the times. So Mac we need to just explore is an option available because this is a Teradata licensed version. We have to check any versions available for Mac as well because the VMware player, I think it support Mac as well, right? If I'm not wrong.
I think it supports that. Yeah. If you, I mean, Ramya, if you have
VMware
Mac,
player,
you can
yeah,
install VMware.
yeah. So VMware player is a major one. So once it is installed, then we have to get the corresponding version from the Teradata website. You have to register for that. I'll just tell you the instructions basically. We'll see. I mean, I think Mac should be okay. In Teradata, you can quickly check it if you have time. So here we have the Linux, right? So Windows This is Studio Express, Teradata Studio, not Studio. We want TD Express. This is Studio Express is only for the Teradata system. Allow data to manipulate and store built on. I think Studio Express might be different. So that's what I think. It is actually a much advanced tool like a SQL Assistant, Studio Express. So I'm just checking for the database. Let's see. Just a moment. So Teradata Studio Express. This is Teradata Studio. So TD Express. Yeah. So I think this is the TD Express on MacBook Pro. Let's see what is this tag. Well, I think we should have for MacBook as well from this thing. Okay. So he said 40 GB TD image, you don't have any problem. So I think it is fine for the Mac as well. So we need to check the options for to download it. I think it should work.
Okay. Yeah. I can check on
Okay.
that. Yeah.
Yeah, you can explore further on this. You can download the VMware player and the software. You can directly configuration is installation is very straightforward. You get your VMware downloaded and get your Teradata Express for the Linux version. Just open the VMware player and open the image file directly. That's it. So
Okay.
the installation is very straightforward. Only thing is we need some kind of tools like 7-zip to unzip the file because Teradata will be in 7-zip format. So we need to know like where to unzip and also from the line. There will be the instructions for that. So we can try that. Not a problem.
Okay.
Should be okay. Yeah.
Thank you.
Okay. All right. Any questions, guys, before we wrap
The
up on
SQL Assistant.
Pardon me? SQL
Yeah,
Assistant is on the
so the
local
SQL
desktop. Yeah.
it's on the Windows. Okay. Okay.
Yeah, Windows is fine. I mean, you can directly install on Windows version. For
Okay.
Linux, I think you can use the Teradata Express Studio itself. There are two options. Either you can use Studio or the SQL Assistant. Studio is inside the server basically. That's what I'm coming to, because for Linux version they might be not able to install the local desktop like this. Maybe they can use the Teradata Studio Express, which is
Okay.
available in the server itself. That is similar to this is what Teradata Studio Express, which is similar to your SQL. Whatever you can do here, all your queries and all you can write it here. So we don't need an explicit SQL assistant. This is also fine. I mean, if you have a server installed, that is fine. We don't need to
Okay.
explicitly install this. So this is for only our convenience and user interface basically. So this is also good, the Teradata Studio Express. So and this is like similar to the SQL page, right? So you might have seen this now. So you can connect to the Teradata dev, whatever we have. The similar way I'm connecting there, right? So I'm connected to the database now. So I can write all these my queries. Example database. So I'm just showing whatever I'm writing there. So the execution is definitely this one. So this is default database, and then start from students. So this is the data that you can see here, right? The same data. This is much easier friendly, I feel. If you used to this is good. I mean, the format and the IntelliSense will also work. So, for example, say let's start from TD underscore the database dot. If you go to S2U, automatically the table name comes in, right? So the IntelliSense will work better in Express Studio. So that is the advantage. So we have pros and cons. The interface is limited to server here, but it is also good like Express Studio. Okay, you don't need to explicitly have the SQL assistant for you. Okay.
All right, sir. Yeah.
So that's it from my side.